problem by breaking it down into similar subproblems. So how do we break a problem in like similar problem? Okay, like this example, this photo also I can break to similar. So basically, what we can say like we want to find the in the meanwhile I can say like what is dynamic programming. If I want to like basically I didn't have to so basically we have to like understand what is dynamic programming before like you have some basic idea about the recursion. Recursion is the base of the dynamic programming. If you don't know recursion, you can't solve any problem of dynamic programming. People are generally saying that you can learn like bottom up approach, which is like iterative method, but it is very difficult to understand because the only person you can do via like iterative method or like bottom up approach if you had already done that question then you can only write the code of that question. So like dynamic programming nothing but like you are given some problem you have to like break it down in some sub problem like subproblem, subproblem, subproblem 1 and subproblem 2. So this is basically dynamic programming. You have to like via recursion you have to solve. In the recursion, you also know that we can assume that if this is given a result of us and this is also given a result of us, then we can say we can find the result of this. But in dynamic, it is basically recursion. But in what is dynamic programming happen? If we let's say if we say subproblem of this and subproblem of this, like subproblem of this is let's say x, and subproblem of this x and y, and subproblem of this is let's say um, I am taking the random number while random characters. Okay, so we don't have to know why you should give this name. So basically, what I'm trying to say, in the recursion, what we were doing is we want to if we have given some problem, we want to find some sub problems also. So these sub problems have itself sub problem at the end point of this. At the end point of this, we find the base case. If you already learned um, recursion, you have seen that we have to find the base case, like these are the base case, and base case for both solutions is same, like both subproblems are same. Okay, so these are the base case. When this is return something for upper problem, and these subproblems are returning something like to the upper problem, and these upper problem become something for its upper problem. So basically what we can say that we want to find the answer for the base problem, and then we can proceed of finding the uh, main problem answer. But in what is dynamic programming, but what in dynamic programming happen? In dynamic programming basically just what is happening is that uh, you, you you can find some such case like like some such problems, sub problems, where you can like you can in some such problems where you can find some such problems which has like same sub problems, like we can say the sub problem of x, the sub problem this one. Okay. So this is the problem basically. You have to find like some sub problem. Let's say we have the concept. How can I increase the concept? Okay, what is everything? Everything. Like you are given P problem, and you have to find like f of P. F of P. F of P, and you have to find like some sub problem. You have to find the answers, and then you can find the main subprograms. But in what is dynamic programming? This is basically recursion. And if we find some like same subproblems in different like different main subproblem, like in this subproblem we are finding this like uh, subproblem of subproblem, and this is also subproblem of next subproblem. Just before, if we find some subproblems are same, like x subproblem is also equal to m subproblem, then we have to solve only one now. But in the recursion what we are doing is we have to solve both the cases, because but but if we solve this only, then why we need to solve this? It is basically time consuming. So what we can say here is we can store this value in something like array, and in generally array. Uh, we can store this value in some array. So if we find some is useful, then we can store this array in in an array, and we can store these values in an array. So if and then in the next step, if like I have stored the x value in an array, not this value, we have to store all the value, all the subprogram value. So let's say this part is completely done, and we have to solve this part. Then we reach this position, and we can say that I have already solved this problem. Why Why I would have to solve this again? Then I directly return to the function from here. Then we don't need to solve this part of the, I can see. Then I don't need to solve this part of the recursion. So basically it is time consuming to solve these subproblems. So so storing the subproblems answer and reusing it, that is called dynamic programming. You have to understand, if we want to find like subproblem answer and we we don't need to solve again and again that problem, then what we have to do, we have to like store these sub problems in the something, we can say like an array, and like 1D array, 2D array. What we like, how many variables are in our function that we need to store in data. So this is called like what I can say is that this is called as dynamic programming. So let's say an example of that, in the basic question, we have to find Fibonacci number. Fibonacci number is, you know already, I think you know already. Then you are thinking here to learn dynamic programming. So what is Fibonacci number is head of head of x is equals to head of x minus 1 is head of x minus 2. So this is basically a Fibonacci number. So what we need here is, if we want to solve the main problem, we have to solve the subproblem. But in these subproblems, we are finding some, like I can say here is, if we want to find like 6, if we want to find 6 value, then we have to previously solve 5 and 4, and also so basically what is Fibonacci number? We want to find Fibonacci number of x. If we want to Fibonacci number of x, we can say that we have to find x minus 1 plus fib x minus 2. So this is basically we want to find. If we can say we want to find f of 6, then we have to like iterate from f of 5 and f of 4. If we want to find this value, then we have to like f of 3 and f of 2 here, and here also we have to find f of 3, and no, f of 4 here is, f of 3 here is, and f of 2 here is. So we can say like these are the same subproblems. So we can, what we can do, we can store these values like previous values in some, like if we are already if we come in this tree, like we have already solved this problem, then why I'm here, then I don't need to solve this problem again and again. So what I previously solved is this problem, so I can directly return from here. Okay, so here I can like can tell. talk about what is code. So the code is like I think the code is like integer for the written this one. Like we can say that it is we want to find flavor of annually, then what we need to do? Here is some base case because we have to stop the recursion function because basically it when recursion when it is gives some stack we want to find like f6, then it is create f5, and if when it is reached on the base case then it will remove. The removing step in this recursion tree we call returning. The removing step in this tree we call the returning. Like in the base case, you return from here something. Then in what the mean we returning in the recursion tree? What the mean in stack form? In the stack form, we are basically we have to push that element. Like we have to find that element. This is the working on the recursion condition. Like, and if we want, like if we were removing here from here it is, then it is on the end of the tree working. Like if you're removing from here, like it is returning from the tree. So when we reach the base case, we start removing the element and uh, say to previous element I have some values and you need to return from here, then we will return all the element and finally we will like remove this element. So recursion itself create an of and space. This thing I want to show you that like recursion is also a O of one space, O of n space we are using basically. So here in the Fibonacci, here is comes some base case, and here is you have to find integer some x value using recursion. What is recursion? Recursion is firstly I am writing the recursion code. Then we will transfer it into the dynamic programming code. The Fibonacci n minus one plus Fibonacci n minus two, and here you return the x from here. What is base case here? What you can think the base case is? The base case, because Fibonacci is not going into the negative number, so we can say is fib of 0 equals to 0 and fib of 1 equals to 1. These are the we know that these are the already given number in the Fibonacci series. So we can say from here is these are the base case and f of 1 is 1 and f of 0 is 0. So if n equals to 0 or all, this is the or operator. We can say that if this true and this separate true, then it returns true value, and n equals to 1, then return n itself. Okay, so this is the basically recursion code. Now I am going to convert this into dynamic programming code. So here what is dynamic programming code is, so dynamic programming code nothing but basically we want to transfer, like we are memorizing the previous thing which I already done that. So I don't nothing I need to do is but I have to return the previous thing was what I have done. Okay, So how can I say that? I need to these are the include head and namespace standard code, and this is our Fibonacci function. And this is our main function. Then what we can like I can create an array of size what range I have given integer of dp. I am generally taking the name of this dp array because I use dp here. You can take any name that you want. I generally use dp word, so I can take maximum value of my maximum limit of my given question here. In the meanwhile, and while I'm calling the Fibonacci, I can I can say like means of function. I can call means of function. What means of function is do it is basically fill that array in -1, 1 and 0. These three values it can fill in O1 time. Okay. It is basically taking some value, array name, array and vector name, and it will fill some values. Like I have to give size from size of dp, size of dp. Okay, so I have to call Fibonacci here, and while I'm calling, if I have to write the base case from here. What is the base case? dp of 1 and n equals to 1, then direct we can return dp of n equals to n. Okay, so on here, if I have already calculated that value, if dp of n is not equals to, if it is not equals to 1, it means I have already filled this value, then I have directly written that value. I can directly return that value dp of n. And else integer we have to find x. X is what? And not taking x and directly putting this value in the dp. It is basically nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the final value, and I have to return this value. So this is the code of the dp solution. So it is really very simple code. I have to call the function and return type. This is the Fibonacci. This is the very basic code of it is a very simple DP programming problem. You can see from here, if you don't get right for the video, sorry about that, because I have recording this video using my and I I I I या चलो हिंदी में करते हैं मैंने एक हाथ से पकड़ रखा है अभी, इसलिए मुझे थोड़ा सा प्रॉब्लम हो रहा है, थोड़ा दिख नहीं पा रहा. So it is basically this is the basically the dynamic programming code of the person. Okay guys, I think you learned something from this video. If you learned something from this video, hit the like button. Thank you. If the video is not best, I apologize for that. I'm sorry for that, but I will try to make my best. Okay, thank you.